Well, hi, good morning. Thank you for coming and spending some of your time with me while I work on this radio. I think I'm in the last stage of replacing a few capacitors now. And I think they're all up in here. There's 3 of them here. And I think, I'm just guessing, they're all involved with the tone control system in this radio. And a little bit of turning of the knob there at one point. The tone control does seem to work. But in any case, I've gone so far with all the capacitors, I might as well do these last 3 wax ones here. Every capacitor I've taken out has tested leaky. Every one of them, every one but one, I think. And so I'm going to do that. Once that's done, the radio is essentially restored in my mind. The rest of these small capacitors like this or like that, I'm going to leave. I don't have any reason to think they're defective or bad. And we're going to go redo the alignment one last time, do it correctly, get a good result, and then it's time to experiment with this radio and another nearly identical radio I'm going to bring in here. So lots more to do in the long run, lots more. So I'm going to go at these capacitors right away. In fact, why don't we just look at them here before I get into it. They all look pretty easy to get at. Yeah, these look easy. These 3 look pretty easy. Is there another one in there I'm missing? Could be. Could be another capacitor in here, hidden away somewhere. But I'm going to get those 3 done, and we'll run the radio and see what we got. We just got some warnings on my phone here. Have a look at these. Can you read what it says there? You see the 4 of them. They all came now, 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 and now. And here's what it says. Tornado warning in effect. Tornado warning in effect. Tornado warning ended. Tornado warning ended. 1 minute ago. Yeah, somebody must have pushed the wrong button down at the weather office or something. Something happened there anyway. Okay, got the 3 of them done here. Oh, yeah, I missed soldering one of them. Like that. But I almost missed another capacitor in here, which is the one that's hidden way up in the back here. Electrolytic capacitor bypass on the output tubes cathode resistor. So we're going to get that guy too. I'm going to solder up the last one. Almost ready. Okay, I got him out of there. Let's see what it is. Microtube electrolytic, 25 microfarads, 25 volts working voltage, type. Well, I think it says CEL10C. I don't know what that is. Made in England, July 1950. Yeah, July 1950. Okay, electrolytic it is, tucked away up in there. With the positive end marked, because this is tricky to tell which end's which unless they mark it. Electrolytic capacitors seldom look like this. Very seldom. Okay, 25. Okay, so that gives me, let's test some capacitors. I got 1, 2, where'd the 3rd one go? 3 from here, and plus 1, but 1 is missing. Maybe it'll show up as we go along here doing this. Okay, 2. Now the reason I like to do this is just because I think it just keeps me on the straight and narrow here. Let's do the electrolytic one first. Okay, so electrolytic capacitors have a leakage in them. If it was in this kind of regular capacitor, well, that would be a problem. But these guys all have a bit of a leakage. So I have to set this on a special calibration for electrolytic. I just do this. Now it's calibrated for electrolytic, but my experience at judging electrolytic capacitors on this tester is limited. I put the positive on the positive, negative on the negative. Okay, and this is how much voltage will this guy take? 25 volts. So really I can only do first test, which is actually 50 volts already. So I'm already overloading this whole capacitor. Well, let's see what it does. Okay, so it opened up part way, but it did it very, very quickly. Let's try that again and watch. So my experience, a 25 microfarad capacitor would take 4 or 5 seconds to charge up. And let it sit here for a moment. Actually, I don't think there's any charge in it. And we're going to try to measure its capacitance. This is supposed to be a 25, so we should find it on this scale. And let's go look and watch the eye. The all-knowing eye did not open at all. So what happened to 25? Let's go down. Much smaller sizes here. So it's opening, but it's at the end of the travel here, which is a little questionable. It's opening on 0.05 and less. Let's try it here. Do the same thing on this side. No. So again, it's just down at the end of the scale here. These things tend to open all the time. So I don't think we're getting any kind of measurement out of this device for this particular capacitor, but let's not quit now. I got another testing device. At this point I'm rather doubtful about how accurate any of this might be. Well, let's give it a go. So this instrument is like something from the future here in my shop. Every other instrument is scared of this one. Try and get the screen to appear. So screen does not want to appear for you. So what it says is 33 microfarads, 50 volts ESR, 13% loss. The 33 microfarads is pretty surprising. So it's supposed to be 25, it's reading 33. I find most of these tests go high when the capacitor is leaky inside, and I think that's what that is. What do we really know about that capacitor? I don't think we really know much of anything other than it certainly doesn't test the way a good capacitor would test. That's about the most we can say. Now let's try these other guys. These are regular. Good show. These are a regular type of capacitor. Very small. And in the audio circuits doing tone control, there's probably no voltage really across them, but I don't know for sure. 50 volts. What do? These glows and it's not going to open. Leaking badly. That's the way you could put that. The other one I just took out. So every capacitor out here, I think, except for one, has proven to be quite leaky, even though they appear to be still hermetically good, hermetically sealed. Now that guy opened. He didn't open all the way. Part way, probably won't open on this. No. So again, leaky. I believe the leak in here is created by two problems. The main one is moisture getting in. Literally molecular moisture just traveling through the wax, getting through the paper right inside, molecule by molecule, year by year. The other way is there can be contaminants inside the capacitor that the manufacturer could not eliminate. I mean, he's trying to purify the paper that's in here. You can only go so far before it becomes uneconomic to go further. And so there's always some contaminants, some ionic materials in that inside these guys, which in the long run may cause a problem. That's what I think goes on in these. And again, as I've said many times, their position in the circuit is really would affect how critical it is to have a non-leaking capacitor somewhere. In some places, it's extraordinarily important to have a non-leaky capacitor in the radio. That would be like grid blocking capacitors and the like. So we got to put a new electrolytic in there. Don't forget I got to put a new one in. I won't forget. I will do that. So the place I'm going to put this capacitor, instead of way up in here, it's up in here because of the physical size of it. This one I'm putting in is much smaller. And this is the cathode resistor right here. This guy, the red, brown, or whatever that is. So I can go right across that. Oops, not that way, this way. Just like that. And that's a much better place for me to install it than trying to tuck it up way up in behind there. Okay, well, I've turned on my signal generator and my meter here, and as far as I know, I've left everything tuning wise just the same as it was in the last video where I was changing capacitors and then watching the effect here. So we're going to try to do the same thing here and see what happens with what I've just done now. Okay, I think everything's ready here. Just double checking quickly. Okay, dim bulbs. Good. Here we go. So the signal generator, I'm pretty sure, is on the same frequency it was on before. Didn't touch the knob on it, and it's a very consistent machine. So I'm going to guess the radio itself is tuned off a little bit. You know, I may have done that by accident. I think I'm falling short of scientific standards here. Let's tune and see what we find. Make sure the antenna is still connected to the signal generator. Yeah, let's tune for it. Hello, hello, hello. There it is. So on the 5-volt scale, we get a reading of just under 2.5 volts. That's the lowest reading I've gotten the whole time here in doing this. So now we're at... Oh, it's doing the going up thing very slowly. Yeah, we're gonna have to let that. We're gonna have to let this run for a bit. Break time. Well, it's only been a few minutes. Pinned right off. Interesting. Very interesting. What is going on that takes so long? Could just be a tube warming up, I guess. Seems oddly long though. Now, there's my pencil. 15-volt scale, 10.4. Yeah, that's the highest number I got before. 10.5. Let's tune just a little bit here. Nope, that's it. .5. So we've ended up with the highest AVC voltage I have yet seen under this testing scenario. Now, what I want to do is I want to go through the whole alignment process again. And I don't think I want to do it on camera. Slow me down, bore you silly, because you've seen it, and the fun part is watching you struggle through the first time, really. I think after that it's too straightforward to be entertaining. So so that's what I'm going to do. If I find anything really unusual, any big changes, anything that I can interpret some intelligence from, I will let you know. Yeah, I said I would turn the camera on if something interesting happened. Can you believe it? I didn't get through one iota. I didn't get one half a step forward. Something weird has happened. So you hear the radio? Very hard to hear. Why is that? I don't know. It was making the sound you were hearing in the previous segment, and this is a capacitor I was going to put on the grid of V3, which is the first First IF amp, this one here. Actually, it's a mixer. Hold your horses here. Big mistakes being made. Is that V3? Or is that V3? Uh-oh. Big mistakes being made. Aside from what I was going to tell you. V3. Okay, so this is 2, this is 3. 3, I thought this was a BA6. So I looked at the pin out for a BA6. None of this will matter. And then I was going to hook this up to the grid. Now, I may be even making the wrong... I might be making mistakes here, but that's okay. What happened was, the moment this contacted the terminal on the tube, just lightly, the radio's volume went right down. It's still down now. And aside from me talking about it, I've done nothing here. What in the heck happened? So I'm going to repeat that, even if it is the wrong terminal. I'm going to try my best not to touch anything. I'm just holding the capacitor here. We'll just touch that terminal. Not coming back. So the possibilities are that actually disturbed the tube pin contact. I mean, I just barely touched it. Hey, what's happening here? It's getting louder again. Could be the volume control. It's just, you know, it's right down at the bottom here. I've experienced over my entire life doing this kind of stuff moments where when you touch, say, a screwdriver shank or almost anything against a terminal, you'll get an unexpected effect of something often becoming louder, or in this case it going quieter. And I've always attributed that to some kind of discharge coming off the thing, screwdriver or whatever, and that tiny discharge sufficient to upset something that's, you know, right on a knife edge, and just give a little tick and it goes. That kind of thing. I have no idea what it is or what things it could be. There's probably more than one thing that could do that. Here's a case right here. Could be the switch. Maybe I bumped the switch here a little bit. Ooh. That's bad. Radio's, look at ABC is just fading away. Now that could be because I've affected the tuning of the radio. It's no longer tuned dead on, and the AVC takes time to relax. Oh my God. The more I do this kind of work on radios, the more I realize how difficult it really is to get exactly the result you want. And ever since I did the rubber mallet test, I hadn't been able to sleep properly. Okay, and if you saw it, you're probably wondering what's going on too. I'm not going to repeat it, but almost on a joke, I hammered the radio this way, and its performance went right down to almost nothing. And then I hammered it on the other side as if to restore it, and sure enough, it came right back up. That has left me quite disturbed. I'm thinking things like, I spent a long time getting the radio all tuned up, just beautiful. And then off it goes in somebody's car, bounced into the car bounces back home, they get it home, they bounce it up the stairs, they put it down finally. By that point, it's been rubber malleted a dozen times. When they turn it on in their homes, and the performance that they get is, you know, 70% of what I was able to get here on my bench. It's really bothering me. I'm also thinking maybe, you know, while you're doing these adjustments, you should be hammering the radio to try to settle parts down to where they're going to go eventually anyway. So instead of having all these adjustments kind of like so many bricks kind of tipped on an edge waiting to fall, you should make them fall and deal with them when they're fallen flat, if you follow what I'm getting at. So, you know, yeah, lots of questions about the efficacy of putting this much effort into into doing this kind of stuff. But you know what? It's fun. I don't have anything better to do right now anyway. Well, if I ask my wife, I probably do, but I won't ask her. What are we going to do here? Okay, so the performance has gone down right now. The ADC is way down from where it was. We're going to take a wild guess it's just tuning. I'm going to turn it up a little bit so we can hear it. Let's tune it. Watch, it's the ADC that's really telling the story. So again, I have not changed anything. Where did 10 volts go? Band switch a little bit. Oh my gosh, look at that. Oh my. Now, was this a rubber mallet type treatment? I think I'm doing something in the switch, but actually turning the switch puts enough mechanical stuff into the radio to make something else go crazy. You know what I need? It's time. It's time. It's time for the stick repair. It's a small rubber mallet here. Now, did it just go into its proper operation and before what we were listening to was improper operation? Who knows, right? Let's poke around areas here that I don't think are sensitive. Okay. What was that? Probably one of my solder jobs. I've been pretty successful with a stick. And hey, I'm gonna rubber mallet too. Oh, for crying out loud, it's my speaker leads? You're kidding me. Speaker leads or something I soldered up in there? Okay, recent soldering jobs. I didn't really solder anything up here. This guy. I never cleaned this switch. I cleaned this one, the band switch. I never cleaned that guy. Let's give him the hose down. Here we are. Very, very powerful cleaner here. I think a good repair guy would tell you, do this before you do anything else. Just do this. But I'm not a good repair guy, so I like to encounter the problem before I start to deal with it. Is this my style? I mean, because I'm interested in finding things out. Okay, so that's off. That's the first setting on. Power back on. Watching for flames. smoke, fire. Looking at another wax capacitor right there. How did I miss that? It's sitting right there. I have another one to do. I looked and looked. It's because my view is end on. And looking at it end on, it's not easy to spot. Try as I may. Okay, where are we at now? So, AVC wise, we're at about 3 volts. Tuning a little bit. No, the radio's tuning is on. Okay, band, switch, wiggle. Can't get more of that. Tone control wiggle. Hey, what's going on with that? So these last 2 settings are phono. And these are 3 tone settings. And I just turned it off. Well, that is unusual. Now I did notice there's a switch here, and it's switching this voltage. That's part of the tone control. Part of the tone control was a feedback coming into here. So I'm guessing what we're seeing is they're manipulating and fooling around with, you know, the phasing of the feedback with capacitors and stuff, and achieving tone effects that they're after. So tone control is working not by just suppressing the treble, which a lot of them do. It's working by altering the feedback in some fancy, dandy way. Why the AVC goes away? It's going up again. It's doing the go up slowly thing again. And it sure seems to be going up to a better place. But it may not be. It may be louder, but it may not be better. More poking. Bits and pieces may go flying. Down she went. Tuning. See how far I turned that? Wow. Getting about 8 volts on the meter over here. I think I have a new procedure. I don't really know what exactly is being knocked around. Could be everything from the tuning capacitor, could be relaxing on the string. The string may have a touch of tension left in it, and I'm banging and the tuning capacitor is drifting a little bit and I'm just drifting it back. Could be slugs are moving in these coils. Can't imagine they move very much. Can't imagine they would move very much. Could be causing contacts to change. I'm not hitting it hard enough for that kind of thing. I could imagine tube contacts. Yeah, you have the tube sticking out, right, and it has some weight out here, you know. So as you wrap away on the radio, it's going to put a moment of force into the tube terminals. Let us wiggle the tubes. Tube wiggling time. Tube wiggling time. This is bound to have some kind of effect. The question is it the problem that we're after here? Just a little tangle up on some wires. Okay. Just use my finger here, and might as well keep an eye on that meter, which has gotten all the way up to 10. Let's just tune a bit. We got all the way up there again. What am I chasing? Before we do any more, let me just try this control here. Odd. There we go. Things seem pretty good. Let's just double check. Tube wiggling. This is an audio tube. This is a radio tube here. And another one down here somewhere. And the last, there's one right up in here. And then there's one more. Is there one more tube in this radio? There is not. So it's not a tube pin thing that's going on. It went up. I could hear it get better, and then it went down. Now again, what went? Is it just tuning? No. See, look at this. We can't get up as high. Oh, now we can. Higher. 11. The thing, all this time I've been aligning radios with screwdrivers in slots and slugs when I could have been using the grand mallet. Get the job done quick. Complete alignment all at once. Every part straightened out. Whack. I really gotta wonder. Okay, so the situation now is I think I have a radio that's quite stable. I think it's where it's ready for the final alignment push. Okay, let me start up the radio here. Now, last time around, I did the alignment by watching the audio output variation on that meter there. But this time around, we're going to do it by paying attention to the AVC voltage that's coming here. AVC voltage represents the output of the IF. Oh, who's that? Somebody at my door? Come in. Come on in. Come on. Peanut, come on. Push that door. Come on. Good cat. What are you doing down there? Come on. Okay, so you gonna come in? Come on in. Come on in. Okay, cat's all happy now after a few minutes of lap time. Now, right, I was going to figure out which slug it is that is giving the trouble and then work on that slug. So it's a slug that is at its maximum. Is it so hard to see here. This track I left on. Is it this slug? Can't get the screwdriver to seat here. What's up with that? Oh, you know, the slug turns so easily. Well, this is not the stuck one. We should take a look at what's happening on the meter there. Now this is at 458, so this isn't even valid what I'm doing at all. But this is not the stuck slug. What about this one over here? Is this the stuck slug? Well, yeah, it's at its limit there. Now, see how it went down? I'm going to change the frequency of the signal generator. Went in the right direction. I can turn it a little bit further. This is what I want to do. I want to push these a little bit. boy, I tell you. No, I don't. You know, I'm using a metal screwdriver with very, very sharp corners on it. It could end up putting almost all the stress right where the corner is meeting the slug. The slug slot is a kind of a rounded tub-shaped thing. So you could imagine that the point on these corners is what's contacting the slug. And someone's at my door again. Who could that be? Holy smokes, man, the distractions are coming left and right. Okay, stuck slug. Looking from the top now. Here. There we are. Okay, I should keep an eye on the meter. Yeah, this slug is stuck. You know what? Wow, it's stuck in both directions. There it goes. No. So this slug I'm turning has a turning, like a free turning area of only a third of a turn. It's not doing anything on the meter. Well, it is a little bit. Wow. So what do you do about this? Push a little past. What am I pushing against? Wax? Oh my gosh. Here, let me just get off the... This is what I'm doing here. So it's got almost a full turn now, but you know. Yeah, there's something in there that's... Oh, just something just came free there. Okay, well, okay, now what to do now? We want to move this slug in the beneficial direction. So what I got to do, I got to do 6 things at once. Can I put this down? Just let go of it? Yeah, I can actually. He's talking to himself. Hey, that's what I do all day long. Okay. Now, problem with this is I'm going to step right in front of the camera when I do this. Maybe you can see around behind me. The slug is in its stuck position. I want to, in one limit, I want to move the signal generator towards where we want to go and see if that meter goes up. He says, no, I'm total roadblock. Okay, you can't watch everything. So we're at 457. I'm going to go towards 455 and see if that meter, what's the meter do? Here we go. Okay, I'm moving. Meter going down. If I go the other way, meter going down also. So it's like tuned right to 250. So let me put this frequency down just a wee bit. Really, and then oh yeah, the screw, I left it in. I will now attempt to turn the screw in such a way as to make this come up. What we're going to do is we're going to end up finding the frequency closest to 455 that I can get to. That's going down, that's going up, so it wants to go more this way. But this is the stuck way. Wait a minute, I got it past something. You know what, I've unstuck this slug. Whatever is in there, I have gotten past it. Excellent, okay, well, you know what we can do now? Put this on 455. Okay, 455. Put in my... I'll try to get a peek on this. Peek there. Do underneath. That was the top slug. This is the bottom slug in the same transformer. See, that top slug was close to 455 the whole time. It was stuck, you know, stuck in the right spot. Okay, go back up to the top slug. There we are. It's weird. it got stuck there for a minute, and then it just suddenly came free. So there's some debris inside. Now we're going to switch to the other transformer. I'll start with the top slug on the other transformer. We're doing all this at 455, right where it should be. Okay, so this is a stuck slug also. So this one refuses to move in either direction. No play. Okay, and again, if I keep filling with it, I'll just do it to the point where it cracks. And then we're really in trouble. Okay, going in the bottom slug of the same transformer. Oops, what's going on there? I think this one's very sensitive to the screwdriver. Okay, I'm in. Pull the screwdriver out. There we are. Now, try to watch both the frequency and the meter at the same time. Once again, I think I'm going to put it up like this. Can you see it like this? Can you do it? You cannot make it there. Okay, so I'm going to do this. I'm going to turn the frequency up and down and get the max on the meter there. Frequency we're at now 457. So what I'm going to do now is I'm going to peak everything at 457 and leave the one stuck slug where it is. We'll see how this goes. I'm accepting the IF being off a little bit. Okay, the bottom slug. Better to have it aligned at some frequency than misaligned at a couple. Other transformer, top slug. Okay, and the bottom slug. This one's affected by the metal screwdriver a little bit. Get in there. There. There we are. That's what we're going to get. What we're going to get. I'll say it again. 5 volts. Okay. That's the IF aligned. So, okay, I put that on video because the first time through I got into the stuck slug problem and I really didn't deal with it 100%. Now I think I've got the best result I can reasonably expect. So, from here, it's correcting all the other alignment things. Again, I don't think I want to put it on video. I'm not expecting anything weird. Huh. Listen to the distortion now. Wow! What is that? It seemed to get worse as I went up in bands. Okay, it's a really weak signal there. I've never really heard something like that before. Wow. What happened to this radio here? Okay, so I want to be on 17.8. Pretty darn close. Okay, we'll go up there. Just ignore the funny noise. Oscillator of the 16 meter band. 16. There we go. That's not it, is it? There it is. Oh, with all this noise. There we are. Oscillator done. RF coils. 16 meter band. I gotta say these things out loud or I'm bound to stick it in the wrong thing and then you gotta start all over. There we go. Tiny amount there. 16 here. Ooh. That was wild. It was like it retuned or something, but it shouldn't. Well, I don't know why it's sounding like that. Let's take off the signal generator. Still able to pick it up. Doesn't have that terrible sound to it anymore. Is this really the signal generator we're hearing? Yep. But I cranked its signal up by a factor of 100. You didn't hear a change in the radio. Isn't that odd? Okay, now we want to tune this radio with an antenna. I have been fixing my mangled outdoor antennas. Did not survive the winter due to squirrel attacks. So this guy goes on the wire. Listen to the distortion. It's just horrible. Wow. Something egregious has happened. Top band. Shouldn't be anything here. Be stunned if you pick something up. This band down. 15. You should hear something. If I would have switched the antenna on. I have to run and switch on the antenna here. Wow. Okay, let's try this. Signal generator out of the picture. $17, $15. Something is going wrong with this radio, for sure. I fiddled with these tone capacitors here. Well, that booped something up. I swear it was unintentional if it happened. I may have put this capacitor in the wrong place. That might be the problem. As a radio, it's receiving well. Let's just keep going down in bands. So now we're down to 11. Yeah, it's receiving really well, except I buggered up the audio. And I'll bet you it's this capacitor. I bet you I boot that. One more down. And now we're on the shortwave band? Yes, we're on the shortwave band. Ooh, what's all that about? Getting up around 9 and 10 up here.
We've been talking about Satan's rebellion against Yahweh, and that he wanted to be like the Most High. To sit on the mount of the congregation or the mount of the Moedim. Okay? And he's done this by stealing away.
Distorted on high volume. Now that there's shortwave distortions happening here too, so it's all kind of mixed bag.
But the other 9 repeated in the New Testament. The Sabbath commandment isn't. That's true. But why do you need any of them repeated when Scripture tells us Yahweh is the same yesterday, today, and forever? Never. It is clear from Scripture that the seventh-day Sabbath was kept.
Well, I've either done something to the bias of the output tube when I put this capacitor in here, bypass capacitor, or one of these capacitors was done wrong, but I was exceptionally careful doing it, and that pretty much guarantees I made a mistake. And there still is one bad one in there. Okay, I'm going to call it quits here for today, and we'll sort out the distortion problem tomorrow. Cool. Thanks a lot for watching. Okay. Distortion gone. That's minimum volume.
On one point or another, rejected advanced light.
That's minimum. I can't turn it down any lower. What was it? These. That's all it was. Just this connection. Excellent. Excellent. Great. Hey, have a great day. You too. You too, Shadow. Oh, I gotta go now.